Hello, hello. Welcome to your first set of geometry notes for the school year. We are starting with sections 1.1 through 1.3. These are just the basics. So we have 3 goals with these notes. Remember, you're supposed to be taking these notes. You will submit a picture of these notes for a grade, okay? So our 3 goals are to be able to define and identify geometric terms. We're going to be able to set up and solve equations using segment addition, and to be able to set up and solve equations using midpoint and distance formula. All right, so let's go ahead and start with goal number 1, being able to define and identify geometric terms. All right, so starting with simple ones like point and line. So the important things to remember about a point, it has no dimension. And by dimension, it means like when you think of things being like 3D or 2D, that kind of stuff, those are dimensions. But a point has no dimensions. And it's usually represented by a dot. So it can look a little something like this. This is considered a point. Now, how it is also identified is through its name. So let's say this had a capital A with it. This would be known as point A. This would be the name of it. This is what it looks like. All right, now for a line has 1 dimension. And it's usually represented by a line with 2 arrowheads. So it looks a little something like this. Okay, that is what a line looks like. Now, when it comes to naming a line, it can be named by 2 points that are found on the line. So you could say this is line BC, and if you notice the symbol I put above it, that means it's a line. Or you could call it line CB. But another way a line can be named or identified is by a lowercase, cursive, or italicized letter at the end. So like we have a D here, so another name would be line D. Good thing about these videos is you can pause them and go at your own pace to write down these notes. Okay, so next we have a plane. So a plane has 2 dimensions. And it's usually represented by something that looks like a floor. So it can look a little something like this. Okay. Now when you name a plane, you're looking for 3 points anywhere on the plane. So we have E, F, and G. So we could say, okay, this is plane EFG. Or FGE, or any order in which you want to do that. Another way to name it is sometimes they'll have bold capital letters. That's another way that you can name this plane. So you could say this is plane H. All right, so those are what we call geometric figures. We have points, lines, and planes so far. So let's talk about some special stuff about points. So we can have something called collinear points, and the key word here is linear for line. These are going to be points on the same line. Coplanar points. These are going to be points on the same plane. Right. So, linear for same line, coplanar, same plane. Okay? Now, a line segment. This is going to be a line with endpoints. So if you notice a line before had arrows on it, the arrows means it's constant. It means it can continually go left or right in this figure. So endpoints means it's only going to go from here to here, and that creates a segment. A segment always has a set distance to it, or a set length. So if we wanted to name this segment, we could call it segment JK or segment KJ. If you notice the difference between when we name the line, how we have the arrowheads above our names and the segments do not, that is how you can tell the difference between a line and a line segment. And the endpoints, these are just going to be the stopping points. Okay? Array. Array is a line with one endpoint. Okay, so it's constant on one side and stops at another, and it looks like an arrow, like so. Here's an example of array. Okay, so when you name array, it's very specific. You have to start with its endpoint and then use a point on the constant side. So that means you're going to start here at L, and then M, since it goes to the constant, and then you put the symbol for the ray above it. All right. Opposite rays, these are rays that go in opposite directions. Okay? An example of an opposite ray. I'm going to get a different color so you can see the difference here. All right, so if you notice, it just looks like a line, right? Well, this line also consists of opposite rays. One of our rays could be ray NP. See the direction ray NP is going in? The other ray can go this way. That would be ray PN. See how they're going in opposite directions? Now their names, when you write it down, are going opposite, but the figure itself is. Ooh, almost done with goal 1. All right, intersection, this is the set of points that figures have in common. For example, if two lines cross, their intersection is where they cross each other. Okay. You could also do things like having a plane and a line intersect. That is another example of an intersection. Sometimes it's more than just one point. Like if we had two planes intersect, there is tons of points that they share because it's like a corner of a room. All right, congruent segments. These are segments that are the same length. The symbol for congruent is an equal sign with a squiggle on top. Okay? All right, midpoint. A midpoint is going to be a point in the middle of a segment. Key thing you want to remember is that it's creating two congruent segments. So a visual example of that would look a little something like this. Say B is the midpoint. That would mean that these two segments are congruent. You can notate congruency by having the same number of dashes. All right. Now, segment bisector. This one's kind of the long definition. So you'll probably have to pause after I write this one down. Okay? It is a point, ray, line, line segment, or plane that intersects at a midpoint. You notice I shorthand a lot of stuff. It's just faster that way. So if we have a line, and we have a midpoint happening here, and then we have another line going through it, this is considered your segment bisector. Okay? Alright, so that's goal 1, and you do have an assignment that lines up with goal 1, so make sure you do it. It would be assignment 3 listed on Google Classroom. Alright, so let's start with goal 2. Segment addition is real simple. It's just exactly as it states. It's talking about adding segments together. So let's say you have a segment right here, A, B, C. Now, segment addition is saying that two segments can add together to create the large one. When you're looking at your figures, especially in your assessment, anytime you see something like this, it means, okay, the distance from A to C, that's what that represents, okay? And then we have this right here, A to B, and B to C. If I was to write this as a formula, I would say, okay, my two small ones, segment AB plus BC equals the large one, AC. Okay? The best way to truly understand that is, of course, by doing an example. So, let's complete an example of using segment addition. Okay. And I will complete one that looks a lot like the homework you have. Alright, so here's what we're given. They want us to find the indicated length. So this is what we want to know, the question mark. So we're going to look to see, do we know the whole thing? So do we know the entire length here? We do. It is 63. And it's going to be equal to our two small ones added together. So our first small one here is our question mark, what we don't know, plus our other one that we know, which is 50. Now if you think back to your algebra days, you want to solve for an unknown, you use the opposite operation. So what would be the opposite of a plus 50? Well, it would be a subtraction of 50. And whatever you do to one side, you must do to the other side of your equal sign. So you think, okay, well, what is 63 minus 50? Well, that means our answer is 13. Now, if you were typing this in your homework, all you do is type 13, and that's it. You don't have to write question mark equals. Just put 13 in, okay? All right, now let's practice another one. We're going to do some problems where it's like solve for x. So let's do an example of that. Okay, here's what we know. We know RT has a length of 21, that RS is 2x plus 10, and that ST is x minus 4. Okay. We're going to have two videos here because I'm about to run out of time. Alright, so we do the whole thing, which is 21 is equal to our first one, 2x plus 10, plus our second one, plus x minus 4. So now you need to combine like terms and solve for x. So let's start by combining like terms. So we have 2x and x. That gives us 3x. And we have 10 minus 4, which gives us 6. Alright, now let's do some opposite operations here. We want to start outside x and move in. So the first thing outside of x is a plus 6. So we're going to subtract 6. Whatever we do to one side, we must do to the other. So 21 minus 6 is 15. Alright, now we also need to solve for x here. So this is multiplication. The opposite, excuse me, multiplication is division, giving us that x equals 5. Okay, make sure you watch part 2 of the video to find goal 3.